Welcome to Monday, January 25th. Today is a virtual day for students for the entire building. You will not have a Zoom meeting with any teacher today. We will be in our own meetings through the day. You're certainly welcome to email me if you have any questions, but today you should be working on getting ready for the test on Wednesday. Here is a study guide that you can complete. I'm going to click on it and let you see. It's not very long. It's over all the things that we've covered so far. Today we're going to talk about the enzymes, and then we'll end our conversation with what's on the test. This is a picture of the enzymes. I'm going to go ahead and go through the notes first. So let's go ahead and go to notes and go down to the bottom where we are with our conversation. We've gone over the 4 macromolecules. Enzymes are proteins, or proteins are enzymes. So you'll see here, the enzymes are proteins that act as catalysts. Catalyst is a term that you're going to need to know. Catalysts are cause reactions to go faster. We're talking about chemically. So when you add a catalyst to a chemical reaction, it makes it go through the reaction faster without changing the chemistry. So in this case, when we're talking about enzymes, we're going to see that they match. So it's called a lock and a key. So the enzyme and the substrate, which is what the enzyme attaches to, this is called the active site because this is where they actually interact with one another. The substrate is what the enzyme is going to attach to. The active site is where the reaction is actually going to occur, and those two come together and fit just like a lock and a key. So we'll see that when we come back out of here, out of this note. But let's keep going. How they work. Enzymes lower their activation energy. So activation energy is the amount of energy required for any reaction to take place. So kind of like the roller coasters that you go on, that they shoot you up in the air and then you come back down. I think it's called Top Fuel, is one of the roller coasters I'm talking about. So you'll go back down the hill and then it'll try to shoot you again. So it'll take you back up in the air and try to get you over the hump at the top of the roller coaster to get you to go through the roller coaster. That's exactly what activation energy is. If you don't meet activation energy, then what happens is the reaction returns back to where it was and doesn't actually complete itself. So right here it's showing you activation energy with an enzyme. Without the enzyme, it has a higher spot to meet. So up here at this top of this curve is the activation energy required without an enzyme. So what happens with an enzyme, you have less to have to accomplish that task. It's lower. It lowers that reaction, so it makes it easier for the reaction to take place. So that's kind of why enzymes are nice. They help the reaction to go faster. Enzymes are reusable. They perform the same reaction over and over without losing shape. They can lose shape. We'll talk about that in a minute. The lock and key model, the shape of the enzyme allows it to be specific to a job. So meaning nothing else can fit. It has to have a specific spot to fit. And if it doesn't fit, the reaction doesn't take place. So that has to happen between the substrate and the enzyme. Again, like here it says, shape of this substance has to match the active site of the enzyme. That's what I'm talking about, the lock and the key. A substrate is what the enzyme works on. So remember I told you when we were looking at the beginning up here, we said the substrate is what it works on. This active site is where the reaction actually takes place. And the enzyme is what's causing the catalyst, meaning making the reaction go faster by lowering this activation energy. So it takes less energy is what it basically comes down to. Here's what it looks like in an induced fit model. The substrate, we said that the substrate is going to fit and the enzyme is going to fit together. Right here's where the active site is, where the reaction takes place. Then here's where it actually connects together, right? Then it produces these two separate products that then leave the active site and go off and do whatever they're designed to do. So you have the substrate, the active site, the enzyme complex, and then the products. That's what this one's showing you. Sometimes enzymes can be denatured. When an enzyme becomes denatured, it changes its shape. It can't bond to other substrates. It actually becomes kind of damaged, if you want to say. So they can't actually complete their job. So here's where it's going to show you. And usually it's because the temperature has been decreased to cause something to happen. Denaturing usually can't be overcome. The enzyme is no longer working. So here is an enzyme that then is its active site again is right here, and the substrate's right here. So those two are going to come together to create that lower activation energy to make the enzyme cause the reaction to go faster, which would then make the enzyme be something to help the reaction take place. So if we look at this one, when you say denature, what happens is these two normally would fit together just fine. As we increase the temperature above the threshold, what the enzyme can handle, it causes the enzyme to lose its shape. This shape then prevents the substrate to be able to fit into active site. So then the enzyme is useless. It doesn't do its job. So that is what denaturing enzymes are. Here's a video here. I believe I actually shared this with you too in a different spot, so be sure to watch that. Here's some digestive enzymes that you can take a look at here. And then this is just a practice sheet. See if you can fill this in without looking. And then here's kind of a step. It tells you the first step here. What's the organic molecule? Well, it fills it in here. What's the monomer polymer? And it's right here. Here are the answers. This is going to be incredibly helpful on the test. These are questions that it's going to ask you. So be prepared. Make sure to watch this as many times as you need to make sure you understand enzymes. And we will meet up tomorrow. Let's look at what else is on our list today. So here we have it. We have the substrate, the enzyme, the active site. Those two come together. Then you have the enzyme complex where they come together and are fit. Then what happens is you make products. Those products go off. Oh, we skipped 3. Then you have where they become 2 different products. Then those products come off and do what they're designed to do. Here's a video here of enzymes. And then you should be working on finishing your foldable, which here's the link to the foldable, which is also inside of this assignment. And this is where you attach your foldable to be turned in. You are allowed to use the foldable or whatever resources you need on the test. Be sure to use those sources to your advantage. And we will meet up Tuesday to continue our discussion. Tuesday, we're going to be reviewing and preparing for the exam, doing a couple of Kahoots. Again, if you need anything, please just email me. I will be available by email. Have a great day.